Well, at this time, you should be fairly proficient in covalent naming, ionic naming, and metallic naming. So for all of those reactions, you should be able to come up with most of the rules that will help you be successful at naming those particular compounds. Now this next one is called polyatomic ions. When a polyatomic ion is used in the naming process, you have to apply different kinds of rules. But you might want to say, what is polyatomic? It's really not on the periodic table, is it? Well, it kind of is. Whenever there is an ion that has two or more elements in it, it would be polyatomic. And as you can see in this very first one, if you notice the SO4 part, that's a polyatomic ion. Also, this NO3 is a polyatomic ion. Those particular ions have various charges based on this reaction between, in this case, the SO4 is the 1 element of sulfur and the 4 elements of oxygen. So that's a little bit different. And the way you look things up is you need your polyatomic chart. I gave you all a copy of that. If you don't have one, please make sure you get one, because it's going to make it very difficult for you to be able to name and also build these formulas without it. Let me give you a look at well, before we do that, let's first of all look at our first compound. And I think you pretty much know what this one is. That's lithium. But you probably don't know what this one is. If we were to look it up, SO4, it's located over here on the chart, SO4. Notice it has a -2 charge, and it's called sulfate. So let's go ahead and go back to this, and let's go ahead and try to name it. It's Li2. Now remember, Li comes from the alkali metals. That's lithium. It carries a +1 charge. So to name this, let me see here. There we go. To name this, we're going to look at this part first, lithium. And it is a +1 charge. And then this is sulfate, which is a -2 charge. And this would be sulfate. And this would be a -2 charge. So in other words, if we did the crisscross method from here to here, and this number from there to there, that's how we get the formula Li2SO4. So that's how that part works. Now let's go in the reverse process. Let's say we take a name and let's convert it into a formula. Again, we look at calcium hydroxide. The calcium part, I think you can all get, is calcium. The hydroxide, there's where we're talking about another polyatomic ion. So let's go back to our chart. So let's go the other direction. We take a look at our polyatomic chart. We're looking for hydroxide, and there it is, right there. It's a -1 charge, and there's hydroxide. So for calcium hydroxide, calcium is a +2, hydroxide is excuse me, is a -1. So let's go ahead and go back. So calcium hydroxide, what we're going to have in this particular case, if we look at calcium, and like I said, it is a +2 charge, and the hydroxide is OH -1. Crisscross method, so you put the 2 right here and the 1 here, so that would equal CaOH2. There you have it. And if that's what you put, you're not quite 100% right, because hydroxide kind of travels together in a package. Polyatomic ions are kind of like their own little element, if you will. That particular charge is held together, so the O and the H travel around as partners. So in this particular case here, we're going to change this. We're going to put parentheses around this to show that it travels together. So it'd be Ca, get rid of that, it would be Ca parentheses OH end of parentheses 2. That's calcium hydroxide. That gives you a better understanding that these polyatomic ions are together, and we need to treat them together that way. So let's take a look at another one to name. Again, we have this. We know this is magnesium, and this is a +2. This we don't know about yet because we're going to have to look on the chart. And this one's it looks like it's going to be a -1. So let's go forward. Okay, NO3. Here it is. It's a single charge. Nitrate, -1 charge. So the way we would write this one is magnesium. And this one would be nitrate. And again, this is going to be a +2. This is a -1, and that's how we get that formula, knowing that these particular charges. So the nitrate is another polyatomic ion that travels together, NO3, and then magnesium nitrate. Now the last one. This one again is fairly straightforward. We've used this compound before in the lab when we did the reaction labs. And Cu is copper. And then the SO4, we know that is a sulfate from the one above it. And we'll just put sulfate. Again, we got all of these from our polyatomic chart. And that's what you're going to need to complete the worksheets I'm going to give you, so you can have more practice on work with polyatomic ions. And again, you'll need that chart to make that happen. So to give you an idea of how that all works together, check this chart. That's the table of polyatomic ions. That's the thing that'll help you put it all together. So thank you very much. We've kind of completed all of the different nomenclatures. So it's important that we practice now. So we have a variety of different worksheets for you to practice your naming using the all of the rules of each of those 4 different types. And that would be covalent, ionic, metallic, and of course the polyatomic ones. So work together, and we'll see you in the lab next week. Thanks. Bye.